In this video, we'll continue looking at how to graph linear inequalities into variables, looking at specific examples. In the first video, we had talked about, in general, the two things that you need to draw when you're graphing the solution set for inequalities. The first thing is to graph the boundary line. The boundary line is, you draw it the same way that you would draw any line into variables. So you could use y equals mx plus b form, you could use x and y intercepts, you could plot points if that's what you need to do, whatever you need to do to get that line down. When you are drawing the line, you need to be conscious of whether or not the inequality is strict or non-strict. If it's a strict inequality like less than or greater than, you're using a dashed line, and if it's non-strict like less than or equal to or greater than or equal to, you'll use a solid line. And then you're going to shade the half plane that contains solutions. You could always use a test point, any point that's not on the line. If that test point works, you shade the region that includes it, and if not, you shade the opposite region. You can also look at the inequality symbol to help you to determine that, and we'll focus on that today as well. All right, so we're going to look at 5 examples in total. The first 3 you see on the slide. The first one, y is greater than negative 3x plus 4. So this is already solved for y, so I can use the point slope. I was using y-intercept and slope. The y-intercept would be 4, the slope would be negative 3. Since this is a strict inequality, greater than, I'm going to use a dashed line. And so I have my inequality written here. So I'm just going to use a scale of 1, so I'll mark 1, 2, 3, 4, 5 in each direction. 1, 2, 3, 4, 5. Okay, my y-intercept is at 4, so I'm plotting a point at 4. My slope is negative 3 or negative 3 over 1, so that means I'm going down 3 units and 1 to the right. So down from here, 1, 2, 3, 1 to the right. And I can do that as many times as I want. 1, 2, 3, 1 to the right. So I'm going to connect these points with a dashed or dotted line because I am not equal to. So I'm drawing the boundary line, but that boundary line is not included in the solution set. So here is that boundary line. Might be a good idea to use a straight edge so you have a straighter line, even though it's dashed. Right, so I then need to shade. So I'm either going to shade the upper half plane on this side or the lower half plane on this side. I'm going to use a test point, but let's also kind of be conscious of the inequality symbol. When your inequality is solved for y, you can use that symbol to help you. So greater than means that most likely I'm going to be shading in this region. I'll just use a test point to be certain. I'm going to test 0, 0 since it's not on the line. I'll do that down here. When I test 0, 0, I'm going to plug in 0 for x and y, and that's why I like to use 0, 0, because zeros are nice and easy to work with. And I also, if I don't use 0, 0, maybe use a coordinate that has the same points, 1, 1, maybe 2, 2, so you don't mix up plotting or substituting in the wrong spot. So simplifying, this gives me 0 is greater than 0 plus 4, which is 4. This is false. 0 is not greater than 4, which means I'm not shading on the side that contains 0. I'm shading on the other side. All right, and so just some tips when you're graphing by hand. Extend your boundary line, shade in the region. Don't just make these little hairy lines. Like really try to shade in the whole region of the graph that you have. All right, going to the second example. We have y is less than or equal to 3/5 x. Have that also on our graph paper here. All right, so that's the example that you see here. Again, y is already isolated, so I can use the slope and the y-intercept. I don't see a constant here, so that means that I could put in a plus 0, which means my y-intercept is 0. Let me put a scale on here, so I'll just go out to 5 in either direction, 3, 4, 5. -5, and the same thing here. You should always, when you're doing this by hand, always mark some sort of scale so the reader knows what your scale is. Then we can tell what y-intercepts are and slope is from the scale. All right, so I have a y-intercept at 0. My slope is +3/5, so I'm going up 3 and then 5 to the right. 1, 2, 3, 1, 2, 3, 4, 5. And if I want to get another point, but I'm off my grid, I can go back and then change both directions. So I'll go down 3 and 5 to the left. Those points will line up. I'm less than or equal to, so that's a solid line. So I will connect these points using a solid line. Again, you might want to use a straight edge. Extend your line through the space that you have to graph. Now I need to shade. So I'm either going to shade the upper half plane up here or the lower half down below. I can't use 0, 0 as a test point because my line passes through, but I could use any other point that's not on that line. So 1, 1 is a nice point, and that's not on the line, that's right here, so I'll use that. So I'm testing 1, 1. I'll write my test point down below here. So plugging in 1 for y and x. So I have 1 is less than or equal to 3/5, which is false. 1 is not smaller than 3/5. And again, that point, that test point 1, 1 was here, which means I'm shading the opposite side. And again, looking at the inequality, this was less than, so I'm shading below that line. And again, if you wanted to check any of the points in this region that we've shaded is a solution to this inequality. Looking at our third example, 4x minus 2y is greater than 12. So here our inequality does not have the y isolated, so we'll need to go ahead and do that first if we're going to use the slope and y-intercept to graph. You could certainly use the intercepts. Intercepts would be a good method here because 4 and 2 both divide 12, so you could easily find x and y intercepts and that would work as well. But I want to show you the slope-intercept form for this one because there's one important thing that needs to be done when we're solving for y in this case. So I'll go ahead and subtract 4x from both sides. And I have negative 2y is greater than, I'm going to put the term with the x first, negative 4x plus 12. Now, in order for me to isolate y to solve for y, I need to divide by negative 2. Since I'm dividing by a negative, that's going to change the direction of the inequality symbol. So I have y is less than, negative 4 divided by negative 2 is positive 2, and 12 divided by negative 2 is negative 6. So my inequality, when I solve for y, y is less than 2x minus 6. Okay, so that's helpful because if I have the inequality solved for y, I can use that inequality symbol to get my shading and I can avoid using the test point. If I don't solve for y first, I can't use the inequality symbol because I might be shading in the wrong direction. It is strictly less than, so that means I'm using a dashed line. Get my scale here. And my y-intercept in this case is negative 6. 1, 2, 3, 4, 5. There's negative 5, so negative 6 will be down here. So that's my y-intercept. My slope is 2, or 2 over 1. So that means I'm going up 2, 1 to the right. Up 2, 1 to the right. Up 2, 1 to the right. And I can do that as many times as I want. Since I'm using a dashed line, I like to have more points. It just makes it easier for me to visualize where that line lives. Extend the line as far as you can. And I will avoid using a test point here because I know now that I can look at that inequality symbol less than, I'm shading below the line. If it's hard for you to tell what's above and below, I like to think of the line like as a drawing of a hill. So imagine you're a little person kind of walking up the hill. So think about what would be above ground, what would be underground. So if you're a little person kind of walking along this hill, this would be below ground, so that's the less than, and above ground would be the greater than. All right, we have two more examples that we will look at. Number 4, x is greater than or equal to -2. So here this inequality only has an x in it. We've seen equations that are graphed on the xy plane that only have one variable, and those produce either vertical or horizontal lines. So in this case, because there's only an x, the boundary line will be vertical. So I'll draw the vertical boundary line x equals -2. 1, 2, 3. I'll just go out to 3 here. 2, 3 just makes it easier for me to count. I don't have to go out to 5, it's just a preference that I have. Alright, so -2 is here. Remember, when you're graphing a vertical line, you're looking at the x-intercept. So this is the x-intercept at -2. I'm drawing a solid line because it is equal to. So I'll go ahead and draw that solid line. And here, when I'm thinking about shading, I could use a test point, so I could use 0, 0. I'm only plugging in the 0 for x, though. So let's say I do that. I test 0, 0. I only have an x to plug in. So it gives me 0 is greater than or equal to 2, which -2, which is true. So I am shading the side that has that test point, which is this side. You can also think about greater than. The solution set includes all of the points that have an x value that's bigger than -2. So all of the points that are on the right of that boundary line would have an x value that's bigger than -2. And our last example, 8y is less than -24. In this case, the x is missing. You only have a y value. So we'll have to think about the boundary line. So the boundary line in this case will be horizontal because there's only a y present. So let's take a look at what that looks like. I have to solve this inequality for y first. I'm dividing by a +8, so I do not have to change the direction of the inequality. Y is less than -3. And I put my scale here as well. I know my boundary line is horizontal. In this case, it is a dotted line because we are strictly less than -3. So I'll go to -3 on my y-axis and draw that dotted line. All right, so here y is less than -3. Where are all the points that have a y value smaller than -3? Well, they all live down here. And again, you could choose a test point. If you want to pick 0, 0, you're only plugging in 0 for the y. So 0 is not less than -3. That would be false. So you would be shading on the opposite side. All right, that's all for this video.